unsigned?
Positive only.
What?
Unsigned is only the positive value 0 to it is like only positive numbers.
Only positive numbers, yeah, very good. Okay, so it will not have negative numbers, right? It will not have negative numbers. But what is signed then? What is signed?
Positive and negative both.
It will include both the positive and negative values. So now here we are going to deal only with unsigned numbers. So we are going to see how unsigned numbers are represented here. Okay. So now do you know this binary conversions and all? Binary conversion?
Yeah.
Okay. So now you see here 4 is a decimal, right? 4 base 10 means it's a decimal. Okay. I already told we are not going to store anything, what is that, in terms of decimal. Everything should be binary, right? So how do you convert a decimal? This decimal, okay, so this is actually 100, right? 100. In 3-bit it's 100. So if it's 4-bit, okay, if it's 4-bit it will be 0100. Is that right? 0100 if it's 4-bit. Okay. So now the question is, you have 4 bits, then for the 3-bit representation it's 100. Okay. So 4 decimal of 10 after converting to binary in 3-bit. Okay. So binary in 3-bit it will be just 100. That's 100. Okay. So what if you have more bits? Okay. For example, what if you have say 12 bits? Okay. So what do you do with the remaining bits? What they are going to do? Okay. So for that, what they are going to do is that all bits, okay, whichever representing positive values, okay, it is represented using this formula. Okay. So in this formula, okay, so what they are trying to tell, this value, actually x is what? X is value. Okay, x is value. So here it is 4. Here it is 4. Okay. So now what is bn then? Actually bn is nothing but each value. Okay, bn is nothing but each value. So this value, it can be zeros and one, right? It can be zeros and ones. Okay. So what is capital N then? Capital N is nothing but total number of bits. Total number of bits. Okay. So that means, so now I already told if you want 12 bits. Okay. If you want 12 bits. Now we have only how many? 3 bits. Okay. So what do? You are going to pad zeros to 12 bits, all of the remaining bits. Okay. 1, 2, 3, 4. Okay. 5, 6, 7, 8, 9. 0, 1, 0, 0. 4, 4, 12. That means if you want to represent this 4 in 12-bit, actually 3-bit is fine. So this is 12-bit representation, right? So this is 12-bit representation. So remaining bits are going to be leading zeros. Okay. So why do you want to only add? Why do you want to add only zeros? Why only zeros? Why? Because when you add zeros, it is not going to change the value, right? It will not change the value. But what will happen if you change the value to the right? Is there any idea like what will happen if you?
So
It will change the value. Somehow it will change the value, right?
yeah.
Okay. So for example, in decimal, so if you have, what is that? 0, 1. 0, 1 means actually 1. Okay. This is our actual number. So if you try to add to the right, okay, left is fine. So if you add to the right, what will happen? This value is going to change. Okay, value change. So that's why we add zeros to the left. That you remember. Okay, for example, maybe in Viva they ask, why do you only want to add zeros to the left of the number? Add zeros to the left. Value change will be there if you add it to the right. Okay, so that's why. Okay, we do this. What is that? Adding zeros to the left. Okay. Now you see here. So you need to understand how many zeros should be included, right? How many zeros, how many number of bits should be there. So that range should be 0 to x less than or equal to 2 power n minus 1. Okay. For example, for 3-bit. Okay. So 3-bit means, so it is going to be from 2 power 3 minus 1. So that is how much? 2 power wait, 2 power n. So this is actually 2 power n minus 1. No, n is total number of bits. 2 power 2. Okay, so range is going to be from 0 to 7 only. 0 to 7. Okay. And for 4 bit, it will be how many? So you already know, no? So it's 0 to 15. 0, 0, 0, 0, 0, 0, like this. 0, 0, 0, 0, 0, 0, 0, 1, 2, till 1, 1, 1, 1. Okay, so the range is 16. Totally it is 16. So it will start from 0 to 15. Okay. So for 12 bit, okay, what if it's 12 bit representation? So 12 bit representation will start from 0 to 4095. Okay. Actually, this is what this is 2 power n minus 1. Now is it clear? Now is it clear? 2 power n.
Yes.
Okay, so here it is 2 power 3 minus 1. That means 2 power 3 is 8 minus 1, so you get 7. So how many bits you have? You have 7 bits. Okay. So now we'll come here. What they are trying to tell here is, okay, the remaining bits, if it's more than, if you need more bits to represent, the remaining bits are filled with zeros on to the left. Okay, on to the left. So that left zeros are called leading zeros. Okay, because unsigned numbers, they all use all bits for magnitude. All the bits are going to be used for magnitude. Okay, so these are called leading zeros that you need to remember. Any doubt? So I'll simply tell you. If you want to represent some decimal number in a format, okay, or in some number of bits, okay. For example, if you want to represent 4 in 3 bit is very simple. It's 100. But generally, like it's going to be. What if you need to represent it in 12 bit? Okay, so there only 3 bits we know, remaining 9 bits you fill it with zeros, leading zeros. So that's what they are telling here, and there is this formula. So you have to use this formula: x is equal to n20 n minus 1 bn 2n. Okay. Did you understand? Do you have any doubts here?
I think I understood this.
Okay. So okay, so here they have given a very good example. Assume that you have one number 1101. Okay, how do you convert it into, what is this? This is in binary. Okay, so how do you convert it into decimal? Okay, so you yeah. Yeah. So like you have this weighted positions, right? This position is weighted as 2 power 0. This is 2 power 1. This is 2 power 2, and this is 2 power 3. You have to multiply with the position weights and you have to add them. Finally, you get 13. Okay. So now this is how you convert from binary to decimal. Okay. So if you are immediate, so why do, maybe you are very confused. Actually, we were dealing with the immediate operands. No, we are dealing with immediate operands. Why suddenly these things came into this concept? Why? Because if your immediate is non-negative integer, okay, so you just pack with zeros. If you want, if it is a 32-bit number, okay, you have only 3 bit with you. Okay, you have only 3 bit. You pad remaining with zeros. That's why they came here. Okay, did you understand?
Yeah.
Okay, so now this is fine. This is for positive integers, right? So what is this 2 power 0? These all in position weights. You just pass this subject. Okay, I just want only you to pass this subject. Okay. So what if so if you have positive number, that is fine. Okay, you have positive number, then what you do? Then you add it, no. But what if you have a negative number there? 2's complement, do you remember 2's complement?
So make one the zeros and zeros, you make it 1 and then you add
1, right. Okay, so what if your so previously, like we dealt with the sign numbers, right? So this is the way to deal with sign numbers. Now what if you have previously it was unsigned, now we are going to deal with sign. You already told, right? So signed means it's going to have negative and also non-negative. That means positive integers. Okay. So how do we deal here? Okay. So this slide. Okay. So this slide, it represents. Okay. Representing negative numbers in binary. How do you represent negative numbers? Okay. In binary. That's the concept. Okay. Previously it was representing the positive numbers in binary, right? So how do you represent it? Okay. So you know already 2's complement, right? And you need to know one more thing about what is that, negative numbers. Okay. In negative numbers, that means signed numbers. Okay. In negative numbers, actually you have this what is that, MSB? No, MSB means the first bit, most significant bit. If MSB is 0, then the number is going to be positive. If the MSB is 1, then the number is negative, right? Okay. So now you see here what they are telling. So this is actual binary form. Okay. In addition to that, you have this for sign bit. Okay. So this is for sign bit. Okay. So you have bn minus 1 2 power n minus 1. Okay. So this bn minus 1, it is nothing but this is for sign bit calculation. Okay. So sign bit means which bit? This is for MSB. Okay. So this is for MSB and it has a negative weight. So you need to understand that this has a negative. This has a negative weight. Okay. So remaining bits, it's going to behave like normal binary. So these are remaining bits. Okay. So now you see here. So what's going to be the range? Actually, range is going to start from minus 2 power n minus 1 to 2 power n minus 1 minus 1. Okay. For example, if you have a 4-bit number, okay, if you have a 4-bit number, the range is going to be from minus 8 to plus 7. Right? 4-bit means minus 2 power n minus 1. So if you're 4-bit, this is going to be 2 power n minus 1, right? 2 power n minus 1 means it's 7, right? Is that right?
Yeah.
Okay. So here it's going to range from minus 8 to plus 7. Okay. And what if you have n bit 2's complement number? If it's 8-bit, okay, if it's 8-bit, and this range is going to be from minus 128 to plus 127. Okay. So this is the range. Actually, this is the range. So they have given one example also. Okay. So now we'll take this. I'll take my screen. So what is that? You have 1, 1, 0, 1 in binary. Okay. So now you see here. First you take all the bits individually. So you have 1 bit, 0 bit, and you have 1 bit. Okay. So now first bit I already told, if you have a sign number, first bit is always MSB. Right? First bit is always MSB. Okay. So for the MSB, the weight. Okay. So what is the weight? So weight is going to be 2 power. Okay. Minus 2. Sorry. Minus 2 power 3. Why it is minus 2 power 3? Because in the range it's 2 power n minus 1, right? Minus 2 power n minus 1. Okay. So this is nothing but minus 2 power, what is that? 4 minus 1. Why? Because total number of bits is so many. N is 4. N is 4. Okay. So you have minus 2 power 3. Okay. So 2 power 3 minus 2 power 3, weight is 8. Now did you understand? Did you understand?
Yes.
Yeah. Okay. For the remaining, actually this will be 2 power 2. This will be 2 power 1. And this will be 2 power 0. Normal weight. We do like this, no? 1, 1, 0, 1. 2 power 0. 2 power 1. 2 power 2, right? But for this one, it's going to be 2 power minus 3. Now did you understand like where is it, like what are we dealing with? So if you want to add, finally, 2 power minus 3 means how much? It's minus 8, right? Minus 8. Okay, so you have minus 8. 1 into 2 power 2 is 4. 0 into 2 power 1 is 0. 1 into 2 power 0 is 1. So finally, it's going to be 8 minus 5. Minus 8, okay, plus 5. This is going to be minus 3 of 10. That means they have given you a signed number. That signed number is 1001. That is in binary. So they are asking you, so I'll write it here, signed binary. Okay. So signed binary, they are asking you to convert or represent it in decimal. Okay. So how do you represent? Okay. Everything else is same. Okay. All the bits it's same. So you have to take the positional weights 2 power 0, 2 power 1, 2 power 2. But for only the MSB, you have to use this formula. Okay. So this is going to be the weight of this one. Okay. So finally you get this is represented in decimal as minus 310. So this is here we are not dealing with anything. Okay. Just representations. That's all. Right now we are dealing with just representations. Now did you understand? Okay, or else there is one more method also. You take 1101. First you can invert, right? So if you invert, this will become 0, 0, 1, 0. Then you can add 1 more. Then you can add 1. Okay, so this will be 1, 1, 0, 0. So you already know the decimal equivalent of this one is 3. Since this is what? Since sign bit is 1, you can include minus 3. So this is also one way to represent. Now did you understand? Okay, I think so you are in a deep sleep, huh? Oh, I'm so sorry. I'll finish this one. I'll just summarize. We'll wind up. Okay? I'll make sure this is not... that's okay. Okay, so now you see here, you have unsigned. In unsigned, okay, so the range is going to be from 2 to 0 to n power minus 1. That means like 2 power 2, 2 power 1, 2 power 2, right? But for 2's complement, that means the sign numbers. Okay, so the range is going to vary from 2 power n minus 1 to 2 power n minus 1 minus 1. Now is it okay? Now did you understand? So why do we need 2's complement is? Actually, I'll tell you why do we need 2's complement. Okay. What you can do is, if you have 2's complement, if you have 2's complement, okay, so it is easy to implement it in hardware, easy hardware implementation. Okay, easy hardware implementation. Okay, so you can use same circuit for both addition, and this is the main advantage. Okay, so if they ask you why do we need the 2's complement in all these things, so you can use same circuit, okay, for addition and subtraction. Now is it okay? Did you understand? Yeah. Yeah. Okay, so now we'll see like what else is there. Okay, so that is that we have just learned how to implement the same example. No, they have extended it. Okay, suppose we want to extend this to be an 8-bit. Okay, actually you have 1101. Okay, that means how many bits are used? Here you are using only 4-bit. What if you want to extend to 8-bit? Okay, that too, this is what? This is an unsigned numbers, it's fine. In unsigned numbers, what you did, actually you added all zeros, leading zeros. How many ever zeros were missing? That many zeros you can add, right? But here, this cannot be done, but because first bit should represent sign bit, no? Okay, so what they are going to do is, the sign extension is given by this formula, okay? Sign extension is given by this formula. Okay, so you have 1101, right? Okay, so this is 2 power 0, 2 power 1, 2 power 2. Okay, so you all have this rated. Now, for the remaining bits, what you do, okay, it's going to be all bn minus 1, bn minus 1. How many missing are there? That many bits will be there. We'll see like if any example. This is very good. Okay, so the sign extension of 1101 is just 111. Why? Because first bit is 1, no? So how many ever bits are missing? If you want to represent this 1101 in This is in 4 bit. If you want in total 8 bit, okay, you can replace the other 4 with 1 if it's a signed number. How do you say it's signed number? If its first bit is 1, then it is a signed number. If signed bit is 0, then you replace all with zeros. Now did you understand this one?
Yes.
Yeah.